What we noticed is that none of them are actually using database systems. So what they were actually doing is that they were using pandas, for example, and basically accessing the data through them while storing their data in CSV files. That sparked our curiosity because this is not really how you're supposed to be doing. This creates like a lot of issues. You have to code a lot of glue to access your data. These tools like pandas, they're not very efficient in operating data. They don't have query optimizers, for example. So it's like, okay, why are you guys actually doing this? And then we realized that the reason is that they could just do a pip install pandas, for example, and with a couple lines of code, they were exporting their data. So if they wanted to use a database system, they would have to install the system, manage the server, create the tables, write the loaders to parse the CSV files to the tables in the database, for them to actually be able to start to query their data. So we quickly noticed that, okay, there's a space for something. Clearly, people need something that's as easy to use and as comfortable as pandas, for example, but with the performance and the storage that a database system can actually offer.
And in this episode, we talk to Pedro Holanda, who explains the motivation of why it's so useful to create a company around helping data scientists use databases. In other words, people tend to use pandas and CSV files a lot. And this sparked his curiosity alongside a few co-founders of why is there not a better way of using databases for data scientists. In this episode, we explore how DuckDB achieved getting over 2 million downloads per month and how the secret sauce of making things as easy contributed to that success. We explore some of the technical differences between SQLite and DuckDB, but also a bit of the technicalities of optimizing storage, memory adaptation, talking of how to develop extensions, and effectively how DuckDB Labs as a company got going and where they're actually going in the future.
Welcome to Inspiring Computing. This podcast is where computing meets the real world. This podcast aims to trigger your curiosity by talking to proficient and advanced users of MATLAB, Python, and Julia, who use these tools to deepen their understanding of the world by simulating it, exploring trade-offs, and gaining insights that help their companies add more value. In addition to proficient users, we will be also talking to product marketing, toolbox authors, package developers, and library maintainers to see what drives the development and what issues they're solving for others to benefit from.
First of all, welcome, Pedro, to Inspiring Computing. It's been a while since I've been trying to get hold of you, so thanks for joining.
Hi, Gareth. Thank you very much for the invitation. It's a pleasure to be here and to be able to talk to all your followers.
So I first heard you talk at a PyData conference in the Eindhoven region, and your talk triggered my curiosity. And I would like to dive a little bit deeper into the company you work for, the DuckDB that you're supporting, and everything around it. But before we get into too much detail, I'm just curious if can you maybe tell me a few words of who is Pedro Holanda? So you don't have a Dutch name, but you're living in the Netherlands. What's your story?
Yeah, that was exactly it. So my last name is Holanda. That's actually my main motivator to move to the Netherlands was only that. I wanted like this to have a good match between the country and my last name. No, so what actually happened, I'm Brazilian. I was born in Brazil. I lived my whole life in Brazil. I did my undergrad in computer science in Fortaleza, which is the city that I was born. I did my master's in the south of Brazil. And when I was thinking about possibilities of where to do a PhD, I realized that one of the biggest database architectures group, which has where I've been putting all my research for undergrad and masters all the time, it was actually located in the Netherlands. And not only that, but I was already working in a continuation of some of the research done here. So I applied to a bunch of places. The one in Amsterdam, CWI, actually really liked my application, invited me over to give a talk to them, to meet everyone. So that was very nice. To be honest, that's also the only research group that did it. Most of them are just like, oh, you look good enough. You can come over if you want. But here they actually took me in, introduced me first to everyone, introduced me to the institute before even I had to say yes. And after meeting everyone, meeting what they were working on, I was super interested. So it was a very easy, straightforward decision, I think.
And now I'm assuming all the other institutions, when they hear your story of what you've done with the Netherlands, they're thinking twice about how they accept people. But let's not jump the gun here. So I wanted to get you on the podcast because I heard of this thing called DuckDB, right? What is actually DuckDB?
Yeah, so DuckDB, it's an in-process analytical database system. Oh, that's basically all the hot keywords, huh? But what it means is we try to position ourselves as a SQLite, a database system that you run in process, but it's also very easy to use, very easy to install, but completely tailored to analytics. It's of course tailored for transactional workloads, which means that in general you have these workloads that update one tuple of your database or a couple tuples, or gather their points queries. So you basically return just a few tuples. That's the main point of it. But the analytical ones, usually you go through almost your whole data set, but you only need actually a couple of the columns. And usually you do these zoom in operations to try to learn something about your data, and then you zoom in at different segments and so on and so forth. So the way these systems have to be structured are completely different. There have been a lot of analytical databases out in the wild, but if you're familiar with them, you might know that they are actually very clunky to use. They're usually very big pieces of software as well because they have a lot of dependencies. So if you want to install the state-of-the-art analytical database system that's not different from DuckDB, it can be like many gigabytes of executable code. And DuckDB is this small piece that you can just plug anywhere, and it's just very pleasant and easy to use.
So let me see if I get this straight. So DuckDB, so it's an open source project, right? This is not a paid thing. Anybody on the planet can use,
Yeah,
right?
completely open source. Anyone on the planet can use, anyone on the planet can see the code, anyone on the planet can open issues if they find something, benchmark it, everything is completely free to use.
Okay, so it's open source, free to use, and then you as a researcher, I'm assuming that you must have done your research in this area, and you must have come to the conclusion that databases is clunky for data scientists to get up and running. So tell me a little bit more about, when you say it's clunky, pretend that I'm not a database guy. Explain this workflow to me.
Yeah, so I can actually tell you how the idea of creating such a system came from. Basically, that's me. There's Mark and Hannes as well. Mark and Hannes are actually the co-creators of DuckDB. We're all researchers at CWI at the time, so 5-6 years back. And at CWI, you had a lot of these projects that are classical data science projects. So you have, for example, people with a lot of data, they pre-process this data, clean it up, put through some machine learning operation, and then classify some image, or they have their own hypothesis about the data and they want to explore the data and visualize it. So that's their basic workflow. And in all these projects, when we start to go in there, they already have their workflows built, like they're not starting it from the ground. And what we notice is that none of them are actually using database systems. So what they were actually doing is that they were using pandas, for example, or R tables, and basically accessing the data through them while storing their data in CSV files or binary files. That sparked our curiosity because this is not really how you're supposed to be doing. This creates like a lot of issues. You have to code a lot of glue to access your data. These tools like pandas, they're not very efficient in operating data. They don't have query optimizers, for example. So it's like, okay, why are you guys actually doing this? And then we realized that the reason is that they could just do a pip install pandas, for example, and with a couple lines of code, they were exploring their data. So if they wanted to use a database system, they would have to install the system, manage the server, create the tables, write the loaders to parse the CSV files to the tables in the database, for them to actually be able to start to query their data. And there's actually performance complications as well, because with a data frame, you have the data frame running in your Python process, for example. So you can actually access the data very quickly because it's the same, the process have access to that memory space. In a database system, you actually have to transfer the data in a more classical database system. So it goes very slowly because you have to pass all the data you want to access through the database connector. So we quickly noticed that, okay, there's a space for something. Clearly, people need something that's as easy to use and as comfortable as pandas, for example. but with the performance and storage that a database system can actually offer. So that was more or less the inspiration that got us around.
But then just for to help me, so I think then it sounds a bit similar to SQLite, right? So I think when I think of mobile phones, typically people have SQLite running. So that's basically like a file. So you can consider replacing a CSV file with something a bit like SQL, which is getting a little bit closer to the database philosophy. But it's also, I think you called it out, but I just want to reiterate, it's aimed at getting like a couple of tuples, right? So it's aimed at, what's your username and password, a quick lookup of that, but it's not meant to get, I don't know, 10,000 rows of the usage of your phone or everything like that, because I think that is a bit slower, right? So intuitively, I think it's slower. And then on the other side, when I think of large databases or serious systems which are spread across the world, and there's the redundancy, and then there's all these checkups, and then there's rights and access rights, authority, certification, and encryption going on. And it's like, I don't know. And then there's some team of super rocket scientists who can figure out what's going on, who are maintaining these things, and you call them warehouses. And then the data analytics are like, okay, I really don't want to do anything with this. So I recognize what you're saying, that it's not so easy for someone who doesn't come from that world, right? So you coming from that world are like, there's tons of knowledge that people are not using. This is a problem. We need to change that. But is the main idea that you're making it easy, like a pip install DuckDB? Is that the main thing? Or is there kind of other things where it's like that you're leveraging?
I think one of the main goals was for sure to be easy to use and install. And there are a lot of technical challenges that come with only this premise. For example, one of the challenges you can have is by not having any dependencies, or your dependencies must be inlined, because this really facilitates the distribution of the code. And with this challenge, it means that you cannot just, inline, have a bunch of dependencies to do a very small piece of your code, but you actually have to selectively get what you need and get ported to your database system. But that's not all. Of course, there's a lot of research that was even done by AWS as well in the topic of analytical database systems that we implement. So when you compare to SQLite and DuckDB, in the very basics, because they are doing different types of operations, the storage format changes. So for example, SQLite uses what we call a row storage format. So the rows are stored contiguously in memory. And you can imagine that's very fast when you want to fetch one row, right? Because it's already, okay, this starts here in the memory, it ends right here. I know exactly what it is. You shift it there. But it gets very slowly when you have this pattern where you're accessing just a couple of columns,
Right.
because that basically means you need to go through all that table. And then when you change this to the columnar storage, where you store the columns contiguously in memory, which is what DuckDB does, then you have much faster access when you just want a few columns and not like your whole table. So this is one of the
Right.
many changes. There's like ways that the execution engine is implemented, two different execution engines. The way you can apply compression. There are many differences in in the way you optimize for these two different workloads.
So you say it's very trivial for you. So let me just see if I'm catching up here. Right, it's really great for a row. So that's meaning like if I'm user X, I want to know my profile, my age, gender. That lookup is super fast because it's my identity and I get all the columns, right? But I think Pandas is column based, right?
Correct.
So Pandas also follows the similar philosophy that maybe as a data scientist, I don't care about the rows as much. My tables get really long. So what I want to do is I want to get the whole thing at once, right? So I want to do a mean, or I do a split apply, or I do an aggregation function or something. And it could be more or less mathematical. I create my functions, but then Pandas, it gets that entire column, right? But that also, the Pandas uses, that sometimes also creates a bottleneck. And you used a word here, which I'd like to double click a little bit on, is you said the word compression, right? Tell me a little bit more about what do you mean by compression? I mean, you have a Pandas data frame. Are you compressing it or what? Tell me what's going on here.
So you can think of compression for like the basics of compression is that the more similar data you have sitting next to each other, the easier it can be to compress, right? So if you think, for example, about dates. So usually dates, when you store them, is very common. They follow a time series, so you have an increasing number of dates. And then instead of storing the whole dates all the time, you can do delta compression, which is you just store the difference between the previous dates and the current dates. And this can save you a lot of space. There are many types of compression techniques that are similar to delta compression. You also have run length encoding that, for example, if you have a lot of repetition in your data, imagine 10 rows with the value 10. Instead of storing 10 times, you just have one tuple that says, hey, 10 appears 10 times. So you can save a lot of space on that. I don't think pandas itself applies on its data, but in DuckDB, we have been doing a lot on storage compression. And I think that a year and a half ago, we literally had no compression. Now
Yeah.
we implemented like several different algorithms. So you have compression for strings, compression for floating point numbers, the hourly compression before delta, and depending on the data sets you have. So for TPCH, which is like the kind of the holy grail of database systems, I think the line item table we managed to get 6 times lower, like in a year and a half. So we have this whole like framework that allows you to more or less easily implement new compression algorithms as well.
The idea is it's not just that it's super easy to use. I'm assuming if you're getting like that kind of compression kicking in, it must be super fast, right? So that's the other thing. It's not just easy, but it's just like super fast. Is that a fair statement about DuckDB?
Yes, of course. If you can suddenly compress your data on 5 or 6 times, that basically means that your IO will reduce 5 or 6 times and getting it from disk, right? So again, it's literally optimized for all these type of scenarios where analytical databases can be very useful. Yeah.
Right. But if I understand correctly, this is still very much aimed towards an individual on his or her laptop, right? So the idea is, so I think also SQL is also very much aimed towards individuals. And you started this with the idea of not necessarily for, I don't know, a huge corporation to adopt this. We'll get there just now if it is or not possible, but this is more for the data scientist to say, instead of having a CSV file of 50 gigabytes, maybe you could use it in 5. Is that it? And if it's in 5 gigabytes, then, your maths will just become quicker, period, dot. Is that a bit of the philosophy?
Yeah, so of course, the storage, yes, 100%. But then again, as said, DuckDB is not only about the storage, but you also have the execution layer and optimization layers that the libraries like Pandas don't have. And the philosophy is really allowing people to extract the max they can from their laptops. It turns out that these things that we have these days sitting on our tables are actually pretty powerful. And if you have like smart algorithms implemented that can take use of your hardware, you can do like pretty great things. So in DuckDB, we have the philosophy of, we call it, never give up, never surrender. We're always going to execute your query. So even if it doesn't fit in memory, most of our operators today, they actually allow for out-of-memory execution. So you can really go this extra mile. So for example, if you take pandas, if your data doesn't fit in memory, what happens? The thing crashes and burns, right? And your Python application is sorry. With DuckDB, no, we really try to execute it. It of course can get slower because then you're buffering stuff to disk. But it is a possibility. And then you can also exploit a lot of parallelism and use like all the cores you have available. So the whole idea was to really allow people in their single laptops to extract the max of their hardware and allow them to perform most of their analytics in their laptop and not in the server.
Nice. Okay, I understand. So it's actually deeper than I first imagined. So if I'm hearing your story, it's not just the data part, but you're talking about, so I'm assuming if I'm hearing you correctly, there's things like in pandas, right? The order in which you write your code actually has a big impact. So I think more senior developers in pandas will realize quickly that you can do the same thing in multiple ways, but what you got to do is filter things very quickly to reduce the data as quickly as possible. And there's an order of operations actually matter. And I think if you dig deeper, the database world, you guys have figured that out eons ago, right? That is, obviously, right? There's optimizations engines. So when you're calling out DuckDB has smartness in it, is that also what you're referring to? That you can take a query and say, look, I know you want to do this, but there's a smarter way of doing it. We can do it quicker. Is that what you do?
Of course, the whole SQL paradigm is about telling what you want and not how to get there, right? So database systems have evolved, I don't know, the past 40 years maybe, to have really good optimization techniques. The one you referred is called a filter pushdown. So it's the idea that somewhere in your query plan, you have a filter, you push it as close as you can get to the table scan, so you're not really passing a lot of data to the up parts of the tree. And as you put it very well, Pandas doesn't actually have any kind of optimization. So that basically means the user has to specify, hey, I actually have a filter, so I need to be sure that's the first thing I'm implementing there. Otherwise, if I put this filter on the last step, I'm actually passing a lot of data that I'm not even going to read. And the same with projections, right? So if you have a data frame, but you actually only need 3 columns out of the 10 columns that data frame has, you really need to be sure that you're extracting them in your first step. Otherwise, you're passing all these columns to all the operations you're doing. And these are the easy, not the big secret of how to do it. You just really push them down. There's not much secret to be done, but there are way harder optimizations. So, for example, subqueries. Subqueries is a hard problem. Usually, the way the most systems implement this is that you have a function call that points out the other SQL query you have and keeps executing it constantly. DuckDB implements this technique that was developed by Munich, another database architectures group, called subquery flattening. So this basically is a way of optimizing these subqueries to be operators, flattened operators. Gets a lot of performance, but doing this type of optimization is extremely hard. I think Mark got locked in an office for 6 months or something like this. And he's one of the smartest people I know. So if it took him like 6 months to do it, it'll probably take me like 1 or 2 years. So it's a very hard type of optimization, and it's extremely powerful, and it suddenly enables you to do so much more.
So I think so I'm beginning to appreciate more and more the technical beauty of this, right? If I'm hearing you, it's like you're taking all your knowledge from the advanced database knowledge teams and you're trying to bring it to the fingertips of the data scientists without them actually realizing it. But you're always talking a little bit about pandas, and you said pandas is a commonly used tool, but I'm assuming that this doesn't just apply to pandas. Do you have integrations with other common data frames, or is it just pandas? How should I think of it?
For example, we do have many clients. Each client will possibly have integrations with different libraries. Of course, I accidentally inherited the Python client, so that's why you saw me talking in the PyData, because I think by now, probably most of the code there has been touched by me. And what happens in there is that, for example, we fully integrate with pandas, so we're capable of reading pandas data frames and outputting pandas data frames, but we also fully integrate with Arrow. So by Arrow, we can output things like TensorFlow tensors or PyTorch tensors. So we really try to dive into that ecosystem and to be reads whatever data formats they have, and to also output them. Preferably, we try to do that zero copy. Sometimes that's possible, but when it's not possible, we still do this type of integration just to make users' life a bit easier.
So maybe for those who are not familiar with the term zero copy, can you explain that quickly?
Yeah, of course. The idea of zero copy is that you can just access the data of some other library without copying it. So you can wonder, okay, how does this happen? So if you think again about the Python ecosystem or environments, you usually have your Python process, and you can imagine you have your pandas data frame and your DuckDB library all in the same space. And it turns out that pandas, for efficiency reasons, uses a lot of NumPy arrays as columns. And you can think of a NumPy array just as a plain C array with some makeup on top. And that's also what DuckDB is the vectors are basically C arrays with some makeup on the top. So if we just change this makeup on the top, we can start accessing the data from pandas, actually NumPy, without copying it. So there's a constant cost of converting it, because you're going to have to convert some metadata, but the actual data access is for free. And the same goes with Arrow, for example. So Arrow is also a certain type of C vector in the end with some makeup, and then you have to do some conversion of this makeup or of this metadata, and then you can just enjoy the speeds of it.
So then that's a super important point, right? So typically people, I think, are scared of change because they, I've got yet another layer. This is going to be super expensive. And they say, I'm already in pandas. What do I need something else to get it into pandas? And there's always someone saying, to get this thing into my pandas or whatever data format, it is expensive, right? But that's not the case. So you pay special attention to this. And that, I guess, means that you pay a lot of attention to the memory mapping, and I'm assuming you also have a few optimizations around memory mapping as such, right? Because I don't think pandas is that smart in figuring out which types of memory the NumPy arrays live in. Is that the case? I'm not sure.
Well, if you're talking about data types specifically, pandas actually usually tells quite well what a NumPy data type a certain column has. What pandas has that's a bit funky is that when they cannot figure it out, they call it, okay, this is an object type. And then initially you're like, okay, this probably doesn't happen a lot. An object type converted to a string, whatever. And then turns out that it actually happens a lot. And a lot of times this is actually just one type. So we at some point built a sniffer that also figures out the type of these object type columns. And there's okay, it turns out it's just
Ah,
one thing, so we can also do some smart things about it. But what I actually think is super special and powerful about this ecosystem integration is that, of course, like we're not here to replace pandas. That's not the point. Pandas has been around for many years. It's a very solid. It's not, of course, optimized for database operators. It, of course, does not run in parallel. It also doesn't have out of memory execution, but it's used in a lot of places. And it's hard to convince people to do a complete switch. That's also not what we're looking for. So that's why we spend so much time on this integration of being able to read pandas data frames and to output pandas data frames, because basically what that means to the user is like, hey, I have this whole workflow. Turns out there's a little piece of it that's actually super expensive, so I can just import DuckDB here. I can do this operation with DuckDB, output the data frames, and just continue as nothing changed.
oh,
So
yeah,
you
yeah,
just need
yeah,
to
yeah, yeah.
alter that those small pieces that actually are quite inefficient for it.
And it's probably very similar all the time, right? You teach someone how to do that and they start seeing the benefits very quickly. Yeah, I can see that
Yeah,
happening. Yeah.
of course, like as database people, we love SQL. Like SQL is the way to go, in my opinion, in my very unbiased opinion. No, but we do, and I do see a lot of people that come from these data frame libraries that they like more this chaining Pythonic API. So we also support something similar to that. So if even if you're transitioning from pandas to DuckDB, I don't think the learning curve will be
Right.
big. A lot of things will be very similar. The syntax is not exactly the same sometimes, but we really try to pay some attention to have it like not be like a foreign word, no? Like you know where you are.
Okay, so I think it's super cool. So on a technical front, I think this is super interesting, and I like the way that you position it. So I think on the website you say it's the what is it, the SQLite for what's the tagline
I think it's
is
the
S
SQLite for data analytics, maybe. I'm not sure if we're still
yeah
using that one,
SQLite for
but that was for sure like one of the first ones.
and then maybe just to give people an idea of how popular is this kind of used by just a bunch of nerdy people who are visionary, or this kind of beginning to get mainstream?
Uh,
How popular are you guys?
So, in number of stars on GitHub, I think we're almost reaching 9.2 thousand by the date. So, we for sure start to achieve some more. We got some more outreach in the past 2 years, I think. In terms of downloads, we're far from the million downloads per month, and our Python API is actually the one that's the most downloaded. And I think the second one might be the Java, surprisingly. At least was a surprise to us a bit. And I guess the corporate IT world is now using DuckDB as well. But we do also know about some other companies that use it. I think Airbnb, for example, is one of the companies that we've seen that are using DuckDB. It's used for many government agencies as well, because of course, like a good, easy to use open source product. So there's plenty of people and companies that are using it.
So then walk me through this. So you and a few other friends of yours, you mentioned a couple of names. I think Mark was one of them, right? You got together and you said, okay, let's solve a problem. You created this open source thing. It's not implemented in Python, right? Is it C in the backend?
C plus.
C++. Okay, so and then you've enabled to be working in as many ecosystems as possible, Python, R, Java, whatnot. But tell me, how do you then make money out of this? You got to pay the bills. Walk me through what that process is of making money.
So actually, the people that founded the DuckDB Labs company were Mark and Hannes. It's actually the CEO, and Mark is the CTO. And I think Hannes had a vision ahead of his time. I would even say that. It was very impressive because he quickly realized that we could have projects with other database companies or IT companies that would pay us to do integrations with them. So we have a bunch of partners in that sense that can pay us, for example, let's say they have a workloads and they need one very specific type of join implemented to optimize their workload, so they can contact us and formulate a project and say, hey, that's what we want, that's what we need, because we're using you guys have been working very well, but this is like the one of the pieces that are still missing there. So this is the main way that DuckDB Labs makes money. Besides DuckDB Labs, there's also the DuckDB Foundation. So this is a non-profit foundation that's mainly there to help fixate the open source code and further develop the open source code. And then other companies that want to have some priorities on the issues they open, or that depend a bit more but don't really have this type of bigger projects, can participate. And in the end, this money is also used to hire contractors, for example, that might have a look on these projects or to sponsor events and whatnot. So basically, all the money we have comes from this type of partnerships. Initially, there was a lot of discussion about joining into this VC kind of world. So Hannes had a lot of these type of meetings where there were discussions, but I think the main idea of how to proceed was to make the guaranteed way of making money with database systems, which is make it to the clouds. And at the time, we were very interested in actually exploring this whole can we get the max out of your laptop? And what actually happened was, I think, very interesting because this other company was founded called MotherDuck and has a lot of people from Google, from the big table people, Microsoft, I think. These guys are all very good, and their whole purpose is to actually get the DuckDB to the cloud. And they were actually the ones that ended up getting VC funding, and we created a partnership with them. So in the end, we are here to also help them succeed and to enable through whatever, for different types of requests they might have to enable them to succeed while also having a small piece, no, maybe not small, but a piece of their company. So we grow with their success as well. So in the end, Hannes was a genius. He just managed to get like the best of both worlds by being a visionary. I think that there's no other way of putting it.
But you actually started with the DuckDB, right? So the project itself was DuckDB itself, where you started, but then you said make money, you did consulting gigs, and then as well, hold on, this turned into partnerships that people have got specific problems and you were very knowledgeable and you started building in those integration pieces. And then the visionary part, which I did not know, is about this other company, the MotherDuck, right? So there's the MotherDuck, and that's where you're kind of going to the cloud and you're getting a bit more VC money. And the whole idea is to get DuckDB scaling into the cloud, which is not where it actually started. So you started very much on the laptop side.
Very started cool. It's literally like that. We actually started because we had this project at CWI. So we started as very academic. It was mostly Mark and Hannes. I joined them bits like 3 months later, they actually started the whole coding. So I was also coding next to them. And I think the realization, or at least the realization to me, that we could make money out of this, that we could actually find these projects, is that when I was finishing my PhD, I still had 3 or 4 months to go. No, you're done with your thesis, and you just have that buffer time where a lot of bureaucracy has to help. So I was like, you know what? I'm just going to use these 4 months to just code the max I can out in DuckDB. And at the time, I was also looking for a postdoc position or a possible IT employment in the Netherlands. And then when Hannes realized that, and at the time there was no DuckDB labs, right? This was just like Hannes, Mark, and I coding in. So Hannes contacted me and he said, like, hey, Peter, I noticed that you want to stay in the Netherlands. If I manage to find resources to get a postdoc position to you, would you stay? And in my head, this was like, man, this is impossible. Like I've been in academia for a while. You just don't find resources like that. It takes like at least a year proposals. So I would love that. I'm having a lot of fun. I love working with you guys. So let's see. And then Hannes managed to find money literally in 2 weeks.
Seriously? Wow.
He literally contacted everyone he knew. He was using DuckDB. And then with this process, I think he realized, oh, wait, people actually are interested.
Can give me money if I...
Giving us money to expand DuckDB to scenarios they need. And with that, I think was a very natural growth. Okay, we can create a company out of it. Now we have an idea of who the potential clients would be, which type of work they would require. It properly aligns with our goals of like really developing again for the laptop. So our clients are also strategically picked in that sense. You know, it's like things that we also want to do and that we also believe are important for this type of scenario, like we're doing analytics in your laptop. So yeah, that was super cool.
Nice. And how big is the team now? So you keep mentioning the 3 of you, but it's quite big.
No. So I keep mentioning the 3 of us because that's I think where it goes the longest. No, but today I think we are here in the Amsterdam office about 15 people. Yeah. And then we have 3 contractors. They are around everywhere. So we try to get someone in each piece of plants basically. So we have people in Australia, in the US.
But the DuckDB itself, it's still an open source project. And I'm assuming that means that you have a I guess you open up to feedback, right? So if people want to make change requests or pull requests, the idea is they should just go to the GitHub repo and create issues. Is that how you guys work to collect
Yeah.
your feedback from the users?
So there's basically two ways this type of, actually there are three ways this type of interactions can happen. So one of them is by opening issues, but issues are usually related to bugs. So something that should happen didn't happen as planned. Then you go there, hey, here's how you can reproduce it. And then depending on the type of issue, of course, we prioritize it differently. If it's like a crash, for example, or a seg fault, okay, that's pretty bad. We should have a look at it. This should really not be happening. Sometimes can be like an error message that was not very clear, so on and so forth. But there's also the opportunities to request features. So this can be like, I don't know, you have your CSV file, but you want to have this one option to, if there's not a column represented there, just have it as null. So that's a new feature.
Right.
And then with that, there's usually, you can open a discussion on GitHub, and then we'll interact and see if that makes sense to what we want to build as well. Or it can also go through Discord. So we have this Discord channel. I think it has, I don't know, a couple thousand people by now. All the team interacts a lot with the people there as well. And then it's very common that you start a discussion there. It's like, oh, that's actually a pretty nice idea. I haven't thought about it. That's an interesting use case. And then you bring it from Discord and you turn it to a feature request on the repository, and then you end up working on that.
So that's how you build out your pipeline for new features, right? So it's very much user-driven feedback from the world, and you listen and actively engage your community. That's cool, nice. But I have to ask the question. I saw DuckDB, it's still a 0.something, 0.7 or something is the latest version today. Walk me through. Why is it a 0.7? If you get 9K stars on GitHub, you got 1 million downloads or something per month or something. When do you move it into a 1.0? So walk me through the ideology behind that.
Yeah, so this is actually very funny. So the reason to that is because we want to have a solid storage system, and by that point always be compatible with the previous storage. So basically, if you have DuckDB 1.0 and then DuckDB 1.1 is released, your DuckDB file must be read by the DuckDB 1.1 as well, without you having to export your data and import it again. That's what actually will qualify the 1.0. I recently was talking in the PyData Amsterdam, and then someone asked, hey, so when is 1.0 coming? And Mark was in the audience. So I was, of course, like, hey, Mark, this question is for you. When is it coming? Mark said, probably September this year. That's what we're aiming for. And I was like, oh, that's the best case scenario? It's not. The best case scenario is like last year. So we have this goal, of course. It's sometimes very hard to predict when exactly we'll all, mostly Mark actually, he's the one that needs to feel very comfortable with, okay, I think the storage is very solid now, and whatever changes we have from now on are like our changes that we can carry on and always support the previous versions. But that's basically what kept us from getting the 1.0. The plan is that it happens by the end of the year. So let's see how that goes.
So what are these DuckDB extensions?
Yes. So the basic idea is that, let's start off with something that's very simple. So let's say you want to use DuckDB to a very specific problem. Pick, for example, geographic data. So for geographic data, you have your own data formats, you have your own functions to manipulate that data. It can be scalar functions or aggregate functions, and you want to build your own library. And it turns out that instead of, you can of course try to support that in DuckDB, but in DuckDB we try to have this very minimum sets of functions that make a database operate. And an extension to look into geographical data might already not be part of that component. So you can build an extension. And this extension is basically a way that you can develop code to DuckDB that's integrated in DuckDB without altering DuckDB's code. So you can have DuckDB as a dependency of your extension, and by calling the correct functions to, for example, register your aggregate scalar functions or the functions you use to scan your data, you can have all of these work in DuckDB without being in DuckDB. And I think that's basically one of my favorite things. I think it's extremely powerful and also very unique to DuckDB itself, because we build it in a way that you can distribute your own binaries, and by simply doing install extension name and load extension name, things just work. So it's not cumbersome, and we will allow you to basically extend it in however you want. and we will allow you to take care of these more specific scenarios. And you can even think you could potentially build a company on that, because you can build a completely closed source extension, distribute it however you wish, that operates on the open source DuckDB. That's totally possible. And we have a lot of people doing different extensions. So me myself, of one, like I did a lot of work on this extension part. So to also test it as a user would be, I built Scrooge McDuck. So I call it a financial data extension. So for example, I built like, okay, I want to scan financial data. Where can I get it? Yahoo Finance. So then I have a scanner that gathers data directly from Yahoo Finance. And it's, which kind of operations do I need to produce candlestick aggregates, for example, that DuckDB doesn't have? I need this set of operations. So I also implement them in the extension. And then I test, okay, does the distribution and of the binaries also work for a third-party person? So in this case, I am the third-party person because I'm not producing it from the DuckDB inner ecosystem. And yeah, it works. Like it's very nice, very pleasant. It's still like also a way of getting you to start to understand a bit better the core of DuckDB, because you do need to operate in what we call our data chunks and vectors, but it's still not like having to mess around the whole inner parts of DuckDB, let's say.
So then maybe just to play devil's advocate here, so why is that approach better than, let's say, I create my own package and all I have to do is import DuckDB and then I write a whole bunch of Python code around whatever I need? So the approach that you're describing, how does that beat what I just said?
One, if you do, it's probably going to be pretty slow. Or if you do it with Python. In this case, with this extension, you're literally operating in the core formats of DuckDB. So you're literally operating the DuckDB's data chunks and in more depth the DuckDB's vectors. So there's not much more speed that you can get from that.
Right.
And then, of course, you also get from this type of extension that you can suddenly use that in any of the DuckDB APIs. So if you do that in Python, for example, that's not going to be usable in R. But if you do that in the core of DuckDB again through one of these DuckDB C++ extensions, it's available anywhere.
So a person who lives and breathes Python will probably think, why do I have to leave my environment? What's the added value? But there are, in many cases, people who are building tools around Python, which make it easier. And if it's a fundamental part of your team, I fully agree that becomes a pivoting point for people. So the fact that you have that and you thought about it, that is very cool. Not many companies think about it so early. Typically that's an afterthought. Okay, we've done this. Okay, people want to bolt onto it. How do we change the code that it can now bolt on?
But that's the thing. The reason we actually started thinking about these extensions so early on is because we actually needed them. So it turns out that a lot of the modules from DuckDB are actually extensions. And you can think it like that. So DuckDB, for example, can read CSV files and can read Parquet files. I think it's fair to say that a lot of people have CSV files. Most people have CSV, right, but maybe most people don't have Parquet files. So you don't really need to distribute the Parquet as part of the core of DuckDB. And then the people that actually want to use the Parquet, then that becomes an extension, just have to run these two commands when they create their database. Install Parquet, which basically will download the binary that's compatible to their OS and their DuckDB version, and load Parquet, which basically will link the Parquet extension to DuckDB, and that's it. And then you have this very small module that you can distribute everywhere. And that's also what makes it possible to, for example, for people to run in their phones if they want to, because the DuckDB binary is actually quite small.
So I think you articulated nicely where you came from, what you currently do, which is pretty cool. But can you maybe share a few words of where you're going as a team? So is the idea to spend more resources on going to the cloud because that's where more money's coming? Or are you building out the team to be balanced? Is it more integration projects? Walk me through where you're going as the three organizations and maybe some of the cool features that it's like it's being a long to-do on your list.
Yeah, of course. So again, the whole clouds part is actually being taken by MotherDuck. So we are different companies still. So we don't really foresee our future as dependent of going to the clouds, but still on doing this integration and become an essential part of this analytical pipeline. This is really what we're aiming for. And our goal is really to integrate more and more with the tools that are already out there and literally just become essential there. What regards to the foundation, it's really supporting the companies that are part of the foundation and also spreading the word of the duck around. So the foundation is also the part of our own inner ecosystem that allows us to talk to a lot of people as well. And in terms of features, I can talk a little bit about what's my personal feature now that I've been working already for a couple months as a parallel CSV reader. The reason that's challenging and why it's taking me longer than I wished is because in the way you usually parallelize this type of scanners is that you say, okay, the first thread is going to take the first 50 lines, the second thread, the other 50 lines, so on and so forth. So that's usually how it goes for most of our scanners. With CSVs, that's pretty hard because you don't actually know where the line starts or ends. You just have a buffer position. And then you can say, okay, thread 2, you start on a buffer position number 1,000. Where 1,000 is can be in the middle of a line, can be in the middle of a quoted string that has new lines. So it's quite a complex problem.
Because you don't want to do it based on commas. You don't want to say, I'll start on comma 10,000. And if I know there are X number of columns, I know there's so many commas. So you could do the maths a bit like that, but it's not guaranteed. Because when you do parallelism, you need to really go into the memory position. That's how you get your speed ups, because otherwise you're just reading it anyway.
Yeah,
right?
Exactly. The main problem is that you just don't know where the line starts. There's no way of knowing it. So what most systems do when they parallelize CSV reading is that they do one first pass, and that pass is of course blocking. And with that, they figure out like where all the lines start in each position, and then they can just distribute the threads. But that's also not so fast. So I took a completely different approach there. So I actually start in the middle of a line. I walk to the next new line points, and then I try to figure out, okay, this looks like a valid line. I try to insert in the schema. Oops, that fails. And so it's way more cumbersome on implementing it, but it's actually pretty fast. So I got it to a point that I released an experimental version. So it's actually hidden by a flag. Nice. And some people, that's actually what's super cool about some of our users. They are almost fans, I would say, because they go and like, oh, there's a parallel CSV reader I can try. And they really go there. They open issues. So that's super cool. I really enjoyed that part of my work when you see like people really eager to go and try that out. But my goal now is to actually make it the default version. So no flags hiding it. People will use it. And also there are certain situations that this type of technique won't work for the parallelization. So then automatically go single threaded, not having the user setting anything up. So that has been my nemesis for the past 2 months.
And I think most people don't think about that. So the data scientist is, look, it's a CSV file. Just load it, right? It should be one line of Python, period. I don't care what's going on. Just do it as quickly as possible, right?
No, exactly. But it should be one line of Python, 100%. There's no question about that. I agree. And it should be as fast as possible. That's my job. That's a system's job to do it. I just think it's interesting because although it sounds like very obvious, parallel CSV, how hard can it be? Turns out that there are some caveats there.
Yeah, no, I understand. No, I think that will be useful. But then, okay, so that's cool, that's coming. But I also have to ask this question, so you've probably heard it before. What's the story behind Ducks? Do you guys like the search engine, DuckDuckGo? Is that the origin? No, there's got to be something more about this. So where does the word duck come from?
Yeah, that's an excellent question. So the reason for that is, of course, that ducks are very versatile. They can walk, they can fly, they can swim. No, I'm joking. That's a corporate answer. No, so the reality is, what actually happened is that Hannes, our CEO, he lives on a boat near the central station in Amsterdam. And because he was living on a boat when he was younger, he thought about having a pet. And what pet is best than a duck? So he had a pet duck for a while, I think a few months, and then his pet duck grew and went to explore the wild, but he was very fond of his pet. So basically when the system started, he was very eager to have it named as to make him remember about his pet duck. So that was the reason. And I think it's pretty cool as well because every release is actually also tagged to a duck species. So if you check, and there's like curiosities about the duck species. So it's very cool. Like he is extremely passionate about it. And I find it, like super nice to see. And there's also this long-standing tradition of having database systems named that as an animal. So I guess that also fits it.
So then maybe to just wrap up, at least from my side, how can people reach you?
There are many ways, I would say. I usually use Twitter a lot. So if you look at Hollanda_PE, you can find me, or you can also just drop me an email, pedro@duckdblabs.com. I'm more than happy to talk if you have any questions or to provide material if you're interested. I think in the DuckDB webpage, there's already a lot of documentation and how-to guides. So hopefully it shouldn't be too hard to get started. I've also wrote like a lot of stuff using collabs so people can very quickly get things going. But in general, I'm very happy to talk to anyone. So if anyone has any questions or just want to discuss something or maybe have a PhD project idea that they want me to say, hey, that's a great idea. Go for it. I'm very happy to do.
Do you need more contributors, or is there anything that you would like to say? We need more beta testers, or are you good on that front?
Yeah, contributors is always, it depends a bit because the thing is to contribute in DuckDB, it needs to be people that have a lot of very deep database systems knowledge or interest in the APIs actually. No, that's a great idea because we do have APIs that they are less maintained because there are less users and contributors, for example, Julia. So maybe this is something that people would be interested in doing it. And usually the API working is a bit more high level, so people can more easily get their hands dirty there.
So Pedro, I think your story is super exciting, but if people would like to see you live or see your company, do you have any specific events that you guys are going to be going to that people can sign up and join, or what would be the right way to see you in person?
We do have some events that are going to be joining this year. So for example, if you want to see me in person, I'll be at the J on the Beach in a few months from now in Malaga. I'm going to be one of the speakers there. Hannes is also speaking at the QCon, I think in a few weeks in London. So we try to join as most of these data events or big data analytics, data science or PyData, so on and so forth. But we also organize our own meetup. It's called the DuckCon. And this year it already happened in Brussels together with FOSDEM. And in there, basically, we talk. There's usually a talk with Hannes and Mark about what's coming up next. So, what are the next goals, or they call it the state of the duck. So, how the duck is looking now and how it should be looking in the next release. And then we have some guest talks. Usually, one of the engineers talk about one of the things they've been doing. And then we have a guest talk. We can be one of our partners. So in the last one, for example, Sam is one of the other engineers. We talked about DuckDB extensions, which is the way that anyone can actually start extending DuckDB without actually having to touch DuckDB's code. And we had the Mother Duck doing the first demo of their product. So that was also very cool. The next one, I think, will be in San Francisco in a few months. So stay tuned. If you follow the social network, DuckDB on Twitter, you probably will get to know it fairly soon.
This is a great place to end this episode. I hope you found it interesting and it triggered your curiosity in some shape or form. At least enough to have a conversation with some friends and family about some cool, interesting insight of how MATLAB, Python, or Julia are actually used in the real world. If they do find it interesting, don't forget to tell them to subscribe to this podcast